what you see on this paper mental math-wise is exactly what you need for this entire unit. Okay, you need to be able to add fractions where you're subtracting 1, subtracting 2, dealing with numbers like 360, 180, etc. You need to know the 30, 60, 90. Now here's the good news. The two examples of the triangles, this is the only one you need for the unit. So if you know these two triangles we're about to go over, you're going to be fine. Yes?
Yes.
Lastly, circumference. There's only one problem with circumference. It's right now. You won't have any others for the rest of the unit. So if you look at the first one here, we already said, some of you pointed out letter E should have an equal sign here. Thank you. 1 minus 1/2, what does it give you? Okay. Letter B, 1 minus 1/3. 2/3.
Yeah.
1 minus 2/3. 1 plus 1/4 as an improper fraction. Okay, now, I'm just going to say this for the benefit of everybody. Whenever we move forward, where we're adding and subtracting whole numbers, like 1, with fractions, please convert in your head all of the whole numbers to fractions that have the same denominator as what's given. So for example, this says 1/4. What is 1 as a fraction of 4? You need to start to see that. Does that make sense? So when you get to letter E and I say subtract 2, what should you mentally convert 2 to? 8/4. That's going to give me 3/4. Okay? This needs to become second nature to you in this unit for you to survive. 7/3 minus 2? 3/3, is that correct? It's 6/3. When it's 2, denominator of 3, the numerator is twice the denominator, 1/3. 180 minus 45. Mental math, you shouldn't have needed a calculator. 135. 360 plus 60. 180 minus 30. 270 plus 45. Any questions? Okay. Was that easy? All right, now, special right triangles. These are the formulas for each of the triangles. If you take SATs, I believe they give you these formulas, right? Given that the hypotenuse of a 45, 45, 90 is 1, find the length of the other legs. Drawing a 45, 45, 90. Where do I put the 1? Hypotenuse. Okay, now, this is how we use the formulas. 1 corresponds to what side in the formula triangle? Which is the same as 1. Look at the diagram, I drew it that way for a reason. X root 2. So to find what x is, I'm going to solve this equation. Aren't they the same thing? The hypotenuse in this 45, 45, 90 is the same as the hypotenuse in this 45, 45, 90. If I solve for x, algebraically, what do I need to do? Get x by itself. This says x times root 2. Divide by root 2. Okay. So now I have this. Is that a legal answer? No, I have to convert it into what? Root 2 over 2 equals x? Does anyone have a question about rationalizing the denominator mentally? Okay. Now notice, I solved for x. Which sides represent x? The two legs. They're the same because you know that across from equal angles in a triangle you should have equal lengths of the sides. So this is root 2 over 2 and this is root 2 over 2. This triangle, 45 with a hypotenuse of 1, super important to today. Now if we move over here and follow suit the same exact way, so here's my x, here's my 60, here's my 30. This would be, how did they write it? X root 3, and this is 2x. Right? These all match up. Which one of these can I substitute out? The 2x is the same thing as 1. Okay? Now I'm leaving this here for a reason, just because this one's a little bit different. Right? Do me a favor, follow this same pattern, please. Set up an equation, solve for x, and then plug those x values into your other sides to figure it out. Okay, so what do you get for x? 1/2. And what do you get for x times root 3? Root 3 over 2, right? Don't you get 1/2 times root 3, which is the same thing as root 3 over 2. Does that make sense? All right, I'm going to say this again. These are the only two triangles with a hypotenuse of 1 that you need to know, and they are derived from the special right triangle formulas. Now, hopefully, we end on an easy one. Geometry. Circumference of a circle in terms of pi that has a radius of 1. Formula? C equals 2 pi r. C equals 2 pi times, so the answer is 2 pi. Okay? We want to keep the pi there because it says in terms of pi. That's